So we have this problem here. We have 4 compound propositions made up of x and y propositional variables, and we must prove the 3 following questions in order and state whether each of the 3 are valid or invalid, or correct or incorrect. So we have these 3 problems here, or 3 questions. Is the argument P1 and P2 and P3 implies C valid? Is the set P1, P2, P3 consistent? Are P2 and not P3 logically equivalent? So let's answer each of the 3 in order. Okay, so let's start with the first question here. Alright, so is the argument P1 and P2 and P3 implies C valid? So recall that for us to make a argument valid, we need to use either the logic tree or a logic table. I'll use the logic. Now first construct the actual argument. So you have your P1 is X or Y, and P2, X and not Y, P3, X implies, and then our conclusion here is there. So to make your logic tree, or the root of your logic tree, you basically take exactly what you had here, you remove a few symbols, and you negate your conclusion. And as such, you have that root created. So this will act as a root. And now it's important to note that for any argument, for any test for validity, okay? We're testing the validity of some argument. Whenever you have that problem, you must always do the same thing. You take these arguments, keep them the same, keep them there, but always negate that conclusion, okay? Always negate that conclusion. That's like the perfect, not even like the recommended way, that is the defined way to prove the validity of a argument. And an argument is valid. So before we even do any of this, let's keep in mind why we're doing this and what our results will tell us. So an argument X is valid when X has no contradictions, okay? And besides a discrete way of understanding this, just in real world applications, if you're having an argument with someone or debate, you will not, under any circumstances, give them a faulty argument, right? Like a broken argument, because they can deconstruct that very quickly and use that to their advantage, right? They'll prove that you're a weak debater and you'll lose the argument. So you as a debate person or as an argumenter, you must give strong arguments that have no holes, no flaws, and could not be used against you, right? So this is a sort of mathematical way to do that, right? So we've defined a root here. This is the root of our truth tree. And now we can begin by, we'll first expand this statement, X or Y, then we'll do X and not Y, X and not Y. So already we have a contradiction here, and thus with that our proof is actually done. So if at any point we have a logical inconsistency or a contradiction, then our argument is invalid. It doesn't matter if all the paths are dead, we just know from here it's invalid, right? Because if this was an actual, so the way a proof of a argument works is sort of analogous to how you've seen a proof by contradiction, okay? So here we are assuming that all of our premises, all of our propositions are correct, right? So to give some technical terms here, these 3 statements are what we call the premise, okay? So we assume the premise to be true, which is exactly what we did here, right? Assume them all to be true, but then for our conclusion, we negate it. Our conclusion, we negated it, right? So we have not Y instead of regular Y. And this is analogous to a proof by contradiction, because if we ever have a proof by contradiction, so let's say we have X implies Y, what we do is first negate this entire statement, X implies Y, and then we prove that this statement here has contradiction. We'll prove that this negated statement, so if not P is a contradiction, then that means when we had negated it, we negated a tautology, right? So if we had a tautology, if you were to negate this, the negation of a tautology is equal to a contradiction because you're switching every truth value. So all truths become false. All truths become for the same idea, same principle occurs in how we prove an argument to be valid in a logic tree method. We assume the premises are true and that the conclusion is false. And so given these two setup, we can find an argument to be valid if its negated argument is invalid. P is valid, not P to be invalid. Because if not P is invalid, that means our original statement was valid. And the reverse also, we can say that P is invalid if not P is valid. And valid again has to do with the strength of that argument. Our argument is strong if there are no contradictions, right? And of course, we'll say X is invalid. So X is any argument is a contradiction, okay? So if our argument is a contradiction, it doesn't matter if this is a negation or just a regular statement. It is invalid if it has a contradiction. So where are we right now? We know that a given argument X is invalid if it is a contradiction. Meaning that a better way to describe it is that if it has a completely dead logic, so its logic tree no longer functions anymore. It found all contradictions. So if a argument is found to be completely contradicted,